Hey everyone! So if you're building with ASP.NET Core, you know you're making some seriously powerful apps. But you also know that with that power comes a real need for protection. Today, we're going to dive into one of the most critical security features you can add, rate limiting. Okay, let's just get right to it. Is your API under attack, like right now? The thing is, you might not even know it. There are bots and scripts out there just constantly, 24/7, looking for unprotected endpoints to mess with. And that kind of leads to a pretty sobering thought. If you don't have a guard at the door, it's really not a question of if your API is going to get abused. It's just a matter of when. And trust me, the fallout from that can hit everything from your user experience to your bank account. I mean, look at what you're up against. An unprotected API is a sitting duck for so many problems. You've got denial of service attacks that can just flood your server and lock out your real users. You have brute force attacks just hammering away at your login page. And sometimes it's not even malicious. A few resource-hungry clients can slow things down for everybody else. And all of this, it leads to crazy infrastructure costs and a service that's just unstable.
So what's the fix? It's actually pretty simple. You hire a bouncer, a really smart, really efficient, totally automated bouncer for your API. And in our world, that bouncer has a name: rate limiting.
The whole idea is just beautifully simple. Rate limiting basically controls how many times a single client can call your API in a specific window of time. If they get a little too enthusiastic and go over that limit, your server just politely tells them, hey, you need to slow down, by sending back that classic HTTP 429 too many requests error. It is your first and, honestly, your best line of defense.
But here's the cool part. Your bouncer isn't just a brute. They've got different moves, different strategies, or algorithms for handling the crowd. And ASP.NET Core gives us 4 really powerful options right out of the box. Each one is perfect for a different kind of situation. Let's check them out.
Think of this table as your quick start guide. You've got fixed window for when you just need something simple, sliding window is all about being fair, token bucket is your go-to for handling sudden bursts of traffic, and then there's concurrency, which is for protecting those really heavy operations. Let's look at what makes each one special. All right, first up is fixed window. This is your classic ticket counter. It just says, okay, we're allowing 100 people in this minute, go. It's super easy to set up and it works. The only little catch is that a clever user could send 100 requests in the last second of the minute and then another 100 in the first second of the next minute. And that little loophole is exactly what the sliding window algorithm is designed to prevent. Instead of resetting the counter every minute, the window of time is always moving forward, second by second. This smooths everything out, makes it much more fair, and stops those sneaky burst attacks at the window's edge. Okay, but what if your API is supposed to have bursts of traffic? That's where the token bucket shines. Imagine you give every user a prepaid card that holds, say, 100 request tokens. They can spend them all at once if they want, but that card only gets topped up slowly at a steady rate. So it allows for legitimate spikes, but still controls the overall average. And finally, we have something a little different, the concurrency limiter. This one doesn't really care about requests over time, it only cares about what's happening right now. Think of it like a VIP room with a strict capacity. It only lets, say, 10 heavy database queries run at the exact same time. It's all about protecting your most resource-intensive operations from getting overloaded. Okay, that's enough theory. It's cool, but let's get practical. You might be thinking, this all sounds kind of complicated to set up, but with modern ASP.NET Core, it's unbelievably fast. You can have your first layer of defense up and running in just a few minutes. No, I'm serious. 5 minutes. That's pretty much all it takes to get the built-in middleware running and a basic policy in place. This is not some week-long project. It's a huge security win that you can get done on your coffee break. And here's how you do it. It's this simple 3-step dance. 1, you register the service. 2, you tell your app to use the middleware. 3, you apply that policy to the endpoints you want to protect. That's it. Add, use, require. Easy to remember. And here's the code that proves just how simple it is. You can literally see our 3 steps. We use add rate limiter to set up our API policy, 100 requests per minute, fixed window. Then use rate limiter flips the switch. And notice that comment, it is absolutely critical that this goes in before your routing. And finally, on the endpoint we want to protect, we just chain on .require rate limiting. It's clean, it's simple, and it's incredibly effective. Okay, so we've got the basics covered. The front door is locked. Now, let's level up, because a simple one-size-fits-all policy is good, but a truly great security strategy has nuance. It's time to make our bouncer a lot smarter. Let's be real, not all users are the same, so why would you treat them the same? Your bouncer needs a guest list and a VIP list. For random, anonymous users just identified by their IP address, yeah, keep those limits tight. But for your logged-in, authenticated users, you can be way more generous. And if you have subscription tiers, this is perfect for giving your pro and enterprise customers much higher limits than your free users. And this same logic applies to your endpoints. As you can see here, you would never protect your login page the same way you protect a public data feed. That authentication endpoint, it needs a super strict limit, something like 5 attempts every 15 minutes to shut down those brute force attacks. Meanwhile, your main public API can be more moderate, and your premium features can be way more lenient.
So we've put our bouncer to work. We've made them smart. What's the big payoff here? Well, it's about so much more than just blocking a few bad actors. It's about building an application that's more stable, more reliable, and just plain safer for everybody. And the benefits are huge. You are actively preventing denial of service attacks. You're stopping brute force attempts in their tracks. You're protecting your precious server resources. You're making sure access is fair for all your legitimate users, and you are getting control over those runaway infrastructure costs. It's a massive win all around. So let's wrap this all up with your final takeaway, a 6-point protection plan. First, enable that middleware. Second, put your strictest limits on sensitive spots, like your login page. Third, get smart about identifying clients. User ID is better than an API key, which is better than just an IP. Fourth, always return those proper 429 headers, especially retry after, so clients know when to try again. Fifth, log all your rejections so you can analyze them later. And finally, if you're running on multiple servers, look into a distributed cache like Redis to keep your limits in sync. Nailing these 6 points will give you a rock-solid API. At the end of the day, ASP.NET Core has basically handed you a world-class bouncer who is ready and waiting at the door. They're strong, they're smart, and they're easy to hire. So the only real question left is, are you going to put them to work?